So before we even start any examples, I do think it's important to know when you can use law of cosines. Law of cosines works when you have side angle side. So anytime basically law of sines doesn't work. So side angle side is law of cosines. In fact, let's bring that down. Of cosines. And then side, side, side. So I don't know if you remember, those were the scenarios last time we talked about that did not work for law of sines. Those are going to be law of cosines problems. So if you don't have an angle, basically if you don't have an angle and its corresponding side, and there's no easy way to get it, it's automatically law of cosines. So remember, just as a review, law of sines were the angle, angle, side, angle, side, angle, and side, side, angle. So like we don't do, just in case you're wondering, we don't use angle, 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 because that proves similarity, not congruence. So we're using ones that prove congruence. Side, side, angle doesn't always prove congruence, but it does sometimes. And we have a way to still solve for the two triangles if there are two, if you remember from last time's video. So there are the scenarios where you use law of cosines versus law of sines. So notice this problem. We have angle alpha, but we do not have side A, the corresponding side. That is big indication that we're using law of cosines instead. And the way you always start law of cosines, because if you recall, there were 3 different scenarios. You always start with the side that's across from the angle either you have or you are trying to find. Okay, so in this case, we already have an angle. So I am going to go ahead and find side A. In fact, I should pause a little second. For law of sines, if you recall, I always said find the angles first. Law of cosines is the opposite. Always find the sides first and then find angles. Okay, so we're going to go ahead and first find sides. And we've got side A, so I'm going to start with A squared. And then it goes B squared plus C squared, so just like Pythagorean theorem. So A squared is equal to B squared plus C squared. And then you just subtract 2 times those 2 sides you had, so 4 times 6, times cosine of the angle, and it does have to be the angle across from the side you start from, okay? So that is important. These have to be opposite or corresponding, okay? So this should be pretty easy because all you have to do is take the square root of everything and just type it all in and you're good to go. Like way easier than the law of sines, or at least some law of sines problems. So 4 squared plus 6 squared minus 2 times 4 times 6, just takes a while to type in, times cosine of 44, and you get that A is approximately 4.17. Okay, so we're going to find all the sides, all the angles. So I'm going to go put these on the side. And law of cosines is great because there's no such thing as the ambiguous case. So hooray! We love it when there's no ambiguous case. Okay, now we have one angle which is nice because angles are the ones that are gross because they just take a little bit longer, but that's okay. They're not like horrible. There's just a few extra steps. So let's go ahead and find beta. So if we're finding beta, you're going to start with side B. So we'll start with 4 squared equals, and we have A squared, so 4.17 squared plus our C squared minus 2 times, so I'm doing A squared plus B squared if you're wondering, minus 2 times A times B. So 2 times 4.17 times by 6 times cosine of beta. So remember, those have to be opposites. Okay. Everything else actually doesn't matter what order you put them in, as long as they're there. So this is kind of gross because we have to get beta alone. So this is kind of what I remind people. So anything that's added or subtracted or added, so all this stuff is added right here, we're going to go ahead and subtract that to the other side. This right here, notice I'm multiplying it to the cosine, so I'm going to be dividing by all of that. And then at the very last step, you're going to be doing the inverse. Okay? So this is what it's going to look like. So I can, one fell swoop, figure out what beta is. So beta is going to be, so I'm going to do the inverse first. And then we're going to take our 4 squared. So notice I'm going to keep that right here. And I'm going to subtract the 2 I said I was going to subtract. So 4.17 squared and 6 squared. I'm going to divide. Wow, that's a really bad 7. By everything right there. And I've already applied the inverse in the front. That should always go to the front. And then, so, I mean, it was kind of gross, but it wasn't horrible, right? So then you just go ahead and apply the inverse. So let me, and that just takes a second to type it in. Depending on your calculator, you might want to, you might need to put some extra parentheses in. So you might need to do something like cosine inverse, and then do a double parenthesis, 4 squared minus 4.17 squared minus 6 squared, right? And then close off that parenthesis and then divide and then do another parenthesis. So like putting these in parentheses so your calculator doesn't get confused. If your calculator is one where you can type it in exactly like you see it right here, you don't have to have those extra parentheses. But if it's one where you have to like hit divide rather than a fraction key, you're going to have to put in extra parentheses. So just watch out for that. Otherwise, this one's really easy for people to get domain errors. If you're struggling, you keep getting an error, just type just the top in, evaluate that, then just type the bottom in, evaluate that, and then type it into the inverse. So that's one thing I suggest if you're struggling and you can't get it. So I typed that in, I got 41.7 degrees. That was so fun. I mean, like, we should do that again. But guess what? We don't have to, because gamma is so easy to find. Since we already have 2 angles, you just subtract the 2 angles. So the beta and the alpha from 180. And we got 41.7. We've got 44. And you get 94.3. Wow, that was so good. Okay, that is like it for law of cosines. I honestly like showed you how to do everything, but let's go ahead and do a scenario which is just side, side, side. Because in that case, we already have all our sides. We just have to go ahead and find all the angles, which is so fun. So we've got to find alpha, beta, and gamma. So because we don't have any angles, we're going to have to go through the process twice using law of cosines so that we could then find our gamma. Now, I don't know if you noticed, but I always stick with the law of cosines. There are people have questions like, could we use law of sines? Yes, you can. You just occasionally have to be careful about the ambiguous case and making sure you get the correct triangle. So law of cosines doesn't have any ambiguous case. So I just always try to keep it safe, and I just always stick with law of cosines when I start with law of cosines. But let's go ahead and find angle, or alpha. If we're finding alpha, I don't even have to draw the triangle. I know that I am going to go ahead and start with side A, and then the other two are just going to go in their own order. You're just going to square them, just so it's like kind of like doing Pythagorean theorem. Minus 2 times those exact same 2 sides times cosine of alpha. And if you remember, this is the side that we're going to be moving everything over to, so the 9 squared side. So the easy way to remember this is we're going to subtract all of that. This is all multiplication, so we're going to divide, and then you're going to do the inverse. So alpha is going to be the same thing as inverse of all this, and then I'm going to have 9 squared on top. And remember, you're going to subtract the 2 sides, divide by everything else. And I did the inverse in the front already, because I always do that at the beginning. But, and remember, you might have to just evaluate just the top if you're getting the wrong answer. So just try it out, test it out a little bit, and see what you get. But you should end up with 127.2 degrees. 127.2 degrees. Okay, so let's go to beta. So like I said, we've got to go through that whole process again, but now we're doing beta. So some of you might be able to just jump to this step right here if you wanted and just switch out the letters. If that's too confusing, just go ahead and write it out. So if we're doing beta, you start with side B this time. And then it doesn't matter. I can do 6 squared plus 9 squared, or I can do 9 squared plus 6 squared, just as long as they're both there, because the order does not matter. And I'm going to go ahead and do this. So if we do the exact same thing, notice this time 4 squared is the one that's going to be on the very first number, and you subtract, the 9 squared and 6 squared, and divide by everything else, and put the inverse in front. So you can actually go back into your calculator if you wanted and just switch out some numbers. If that's too confusing, don't do it. Just retype it all in. So I'm just switching out because I like to save some time. So we get 20.7 degrees right there. And then the last angle should be the easiest one to do because you already have 2 angles. So just subtract the other 2. That's a 2. That doesn't look like a 2. And that's a 7. Minus 20.7. And just type that all in. Oops. And you get 32.1 degrees. And there would be your answer. So nothing too crazy. Pretty good stuff.